So today we're going to talk about M&V, and all right, so as some of you saw the blurb we wrote on LinkedIn, or we sent an email out, and that's how a lot of you learned about this. Look, you can learn a lot about M&V by reading, BEMP M&V guidelines or the IPMVP, maybe ASHRAE 14, or you can just, those are great resources to learn stuff. But there's a lot that's just not covered in them, and a lot of it is just practical experience. And if you're a new M&V person, or let's say the only M&V person at a company, and you're relatively new to the field, I mean, geez, where are you going to pick it up? I just don't know. You can't read about it, and that's why this is actually going to be a great webinar, because Robert's been doing this forever, taking measurements and running into all kinds of problems, and he's going to tell us about. Well, I don't know what he's going to tell us about. Let's find out. But I'm not going to introduce who Robert is. I'm going to let him do it himself. So Robert, why don't you do that?
Good deal. Thank you, John. And thanks for having me. I'll preface the story by telling him the phone call that I got from you, which was like an interview. It was like, you don't have the gig yet, but let me hear what you talk about. And I was driving up in Michigan, and John was like, I started talking about my interest in field measurements as a piece that we don't focus on. And I slowly convinced John. I mean, he knew it was valuable, but he didn't know what I was going to talk about. So today I'm kind of hoping to replicate that through a conversation with John about things you can run into. And I think for the audience, it's a matter of we focus a lot on option C, right? Utility meters using your option C software, but the other aspect of it in the methodology is option A and B is real measurements. And there's a changing of the guard that we're going to talk a little bit about, of old folks like myself who did these field measurements and the ways that they're doing it in the future. So a little background, yeah, I started my career as a building automation technician. I was fortunate my playground was an exhibition center, and it had been around for years and gone through a lot of modifications. So it was a great learning playground for all the different types of HVAC and lighting. And my mentor was essentially an M&B engineer, right? So a lot of the schooling I got wasn't just to fix what was broke, but to prioritize based on a guarantee performance contract, right? So yeah, that would have been 98. I'm in my 25th year, a little scary to say out loud, and I've been around and I've seen a lot. I'm a field oriented person. I like working on the components, and I think that's kind of the changing that we're going to talk about, my experiences. So my hope for the crowd really is to, whatever your role is, typically in a guarantee or energy performance, to focus on what can happen, what the importance of real measurements are, and hopefully help you do a better job of getting quality measurements.
So you work for an ESCO now, correct?
Correct. I'm with.
Do you mind saying who it is?
Yeah, I'm with Energy Systems Group. I've been here for 5 years, and part of my role here was to further develop our M&V group and to teach and train. So this is kind of in alignment with my gig, right?
And you've been with ESCOs all along, is that correct?
Yes, so, yeah. My first was with Johnson Controls for 20 years. So yeah, I'm an M&V ESCO guy through and through. That's for sure.
Oh, so you've only worked 2 ESCOs. Oh, okay.
Yeah.
All right. So I guess what we were, I don't know if this is how we were going to start. We kind of almost had an outline, and then I didn't bring the outline with me, so I'm just going to wing it. I think we'll do just fine. But I remember maybe it was like 6 years ago, I was with my wife in Mumbai, India, and we were in a van and we were being driven to Pune. And I looked, out the window, and there was this guy, and I don't know what you call what he was wearing. I call it a loincloth, but he was barefoot, had no shirt on, and he was climbing a power pole. And the power pole that I saw, this was in Mumbai, was metal. It was made of metal, and it was shaped like a pitchfork upside down. So the handle was in the ground. They had the 3 tines in the air, and then attached to those 3 tines were wires that were, headed towards other pitchforks. And he was climbing up this thing, not with a ladder. He was climbing it like,
gaffer boots or peg.
Yeah, and he had a wire in one hand. He was going to go connect something to this power pole. It was the craziest thing I've ever seen. Yeah, and I started talking to the guy next to me who happened to be an engineer, and I said, "Did you see that?" And he's like, "Oh yeah. No." And I explained how we take electrical measurements in the United States and how we wear these suits, and these balaclavas and 2 pairs of gloves and all this stuff. And he was like, "Oh no." And look, to me at the time, the way I learned electrical measurements was actually no one taught me. They just said go measure stuff. I didn't know I was supposed to look and see what the voltage is before you go and measure stuff. I just measured stuff, and the only lesson I learned, and this was before I worked JCI, was don't wear your ring. Take your ring off, and don't put your hands in the box, in the circuit box, just one hand at a time, so it doesn't go through your heart. That's all I knew. That was the only rule I knew. Oh, and don't stand in water. And so, yeah, we weren't trained. We just go out and do it. Okay, if you don't do it, you're a coward. Okay. So that was when I was raised. And so then when they started wearing all these suits and requiring all this stuff, I just thought, God, this is overkill. It makes no sense. Nothing happened to me. Nothing should happen to anybody. And I was telling him about how it was in the United States and how I didn't like it. And he's like, oh yeah, in India it's not a problem at all. You can do whatever you want. It's no one here, and I've worked with Indians, in other countries, and yeah, they don't wear gloves, and they get measurements done quickly. I mean, they'll do maybe 100. I don't know if they can do 100 in a day, but I wouldn't be surprised they do 100 electrical measurements in a day. They just do a lot very quickly. Anyway, that was just a quick anecdote. So do you have anything to say about that?
I do. I mean, in my career, some of the safety protocols definitely were not as loose as India. I comically imagine the image of all the wiring. That I don't think they have their version of an OSHA, so they can get away with some of that. But early in my career, we didn't have some of those securities, the safety protocols. And now we have a lot of safety. And a funny story, when I started here at ESG, I was onboarding with our safety manager, and he was ready to breeze over the idea. I was wearing a suit coat, and he was going to breeze over the idea of arc/safety. And he said, nobody here is doing that. And I raised my hand, and I said, well, I will be. And he goes, no. I mean, like live measurements. And I said, yeah, I tend to do that. And I did have to go through some safety training. So we understand that at some points it gets excessive, but it is important. I mean, as you were talking about, I was trained, take the ring off. I was told to, when you throw a disconnect, use your offhand, because if something happens, you won't have to learn to write again. I mean, it was pretty elementary, but the protocols have moved up, and it's for the right reason. But you really tied into another whole segment, which is, that's how I learned too. I had somebody who taught me, but you can't just throw people into that business anymore. And we're hiring, smart engineers out of college, but they don't have that field experience. No. And years ago, we started to go down that model of, okay, well, let's teach them, and let's teach them safety. But that's not a great fit. So part of what I wanted to talk about today is the model of these projects is moving away from having in-house people that know how to do this work and do it safely to using contractors, which I'm okay with, but we own these projects. In my case, it's a guarantee, and we can't just delegate and trust. We have to have a plan and oversee. So that's one of my focuses today.
I totally agree with you. I like the idea of having an electrician do it, because this is what they do. And then you can have your ESCO person working with them say, I want that one, do that one there. And maybe you can be holding the meter and looking at it and saying, okay, this is 12 watts or whatever. So,
and that rolls into it, John. Even as we started to realize that, you say, okay, so let me go hire. Let's say we have a lighting contractor. Well, a lighting contractor, they're all electricians, right? No, they're not. And in all due respect, but they're trained on, when the power is turned off, they're trained on how to replace fixtures, but they're not electricians. They may have an electrician on staff. So when we say things like, okay, let's just have them take the measurements.
Yeah, that's right.
If you go to a doctor, you don't go to any general practitioner for a specialist, but we do with meters. They have to have the equipment, they have to have the know-how, right? So it does take some planning if we're going to go to that, where the contractor model, right?
Yep.
My previous company, I'll add on to that. When they found out I was taking measurements, they were like, we can't have you out there doing that. We can pay somebody at a better price point to do that. From a business sense, it makes sense, right, as a cost. But look at it from the contractors. The contractors are who we hire that are finding these savings for us in many cases. Is it a fox watching the hen house to have them do their own measurements? So this is where we have to understand, what our expectations are, give them specifications, and to make sure they understand.
Yeah, and the other thing about contractors, lighting people, is a lot of them have never taken a measurement before, and so you can hand them your power meter, and they won't know how to use it.
Yeah.
So,
well, I'll share a story on that one. I had a lighting contractor friend of mine, and when they go out and they do their audits of what the work is, they do a lot of this so they can look up at a ceiling and ballpark on a pre-measurement. That's going to be 57 watts, right? And I went out in the field. I was taking the measurements, and he was with me on the audit. And I took the measurements, and these are 2 foot by 4 foot fluorescent fixtures, thousands of them. And my first measurements are coming in pretty stable at around 47 watts.
right.
So we've already lost 10 watts per fixture. And the beauty of it was the guy looks at me and goes, so what's wrong with your meter? I've got this calibrated meter. He's doing a guess from the ceiling. And comically, I had an auxiliary meter, and I did. I went and got another meter, checked it. It was correct. This is part of that conversation I want to share, is that the measurements matter for our reporting, our savings calculations. We really got to focus on it.
Yes, let's talk about lighting first and get that out of the way. So I guess one first question would be, why is it that when you see something and yes, maybe the tables say it should be 57 watts, why is it only 47?
In that example, we look at, like with fluorescent lighting, you can look at it, that there's a lamp and ballast combination. You get to the customer site. What if you open up a fixture and you do a few samples of what wattage the bulbs that they were supposed to be using, but you find out that's not the case throughout, right? This kind of ties through to both sides of it, both the pre and the post. But when we know the specifications of whether it's a fluorescent or a new LED, you might have a cut sheet. And I love this line of the cut sheet says, well, we know what it's going to be because the manufacturer gave us the specifications. Well, shocker, the manufacturer went in a lab and tuned it for the perfect outcome of the best wattage, right? And when you put it in a client's electrical infrastructure of the building, the voltage changes, they could have grounding issues. A lot of things can vary from what the label, what the box said, right? So when you talk about pre's, the fluorescent, yeah, everything from the ballast, the age of the ballast. Typically you have a low, medium, and high driver on fluorescent ballast, right? So when it comes to doing a lighting audit and assumptions, it may be a start, but that's why we got to do the measurement, right?
No, right. No, I know that. So when I've done measurements quite a bit, and I find that, so we often will turn off the light and then we'll attach everything, turn it back on. And I'm reading the watts, and the watts, it won't settle on one number. It just keeps moving around and it keeps going up. And it seems to me, maybe it was my meter, but I don't think so. It just seems that if I wait 5 minutes, maybe it'll get to an equilibrium, but I don't have 5 minutes per fixture. I don't have that kind of time. What do you have to say about that?
So, and you mentioned that when we first discussed it, and there might have been something, I typically, you'll see some settling in when you first power a device on. What you described seemed to be a little bit more than that, right? So part of it is this planning, right? If you're going through a building and you've got your plan of where you're going to take your samples, it would be good to get them turned on and get them warmed up. Whether it's fluorescent or even the electronics of LED, right? It should be warmed up. Typically 5 minutes, right? 5 minutes warm up should be fine. And that would hurt if you were trying to keep moving. But like I said, if you plan ahead. But one of the things I was thinking about for yours that we'll hopefully segue to is the meter accuracy, right? We said we've got a good meter, we've got it calibrated, but we talked about the current transmitter as being an important a peripheral to the meter. And when I was thinking about your example, I ran into this one time. Here is a current transmitter. This one is for a building automation system, but it's not really different. When it's closed, it senses the magnetic field of the wire passing through it. But because it's a split core, these contacts, the iron core surface, has to be clean and make a good connection. And then years ago, I was taking a measurement and the readings were not coming in anywhere near as expected. And I was kind of baffled. And it wasn't until I found that my current transmitter had built corrosion on those two contact points. It didn't come back and tell me it's broke. It didn't read. It gave me erroneous readings. So it really ties back, John, back to your equipment, knowing the peripherals, right? The idea that we have to have a good, stable piece of equipment before measuring, that's more than just lighting. That's boilers, that's chillers, right? Something funny that I thought of when you said
yeah,
that.
Certainly that.
You gave me an image of a cartoon that I saw. It was in a newspaper, and it showed two police officers standing over what was supposed to be the chalk outline of a body at an incident. And instead of a chalk outline, it would look like a snow angel. And when the one cop looks at the other, he says, "What's that?" He says, the guy wouldn't stop moving. And it made me laugh to think of you trying to take a snapshot of a measurement while it's fluctuating up and down. This is real life stuff that you have to plan for in the field.
So, but I found that you turn things off, you put on the probes or whatever, on the wires and all of that, and then you turn it back on, and it still has to warm up, even though it was on. At least that's what I've experienced. But you're saying that you haven't experienced that.
I haven't seen that much of it. Yeah, I mean, the old fluorescents seem they took a bit longer. The electronics do immediately, initially, they'll bounce around a little bit, but they stabilize pretty quickly. I have not had that problem, not on a grand scale of any kind. But you bring to mind the latest combustion analyzers. It used to be that if you're going to start up a boiler, you definitely need, there's no latent heat. You got to get the boiler going and circulating, and that was known. But when you attach the combustion analyzer to sample the exhaust gas, you would also have to watch to see that the points that it measures stabilize. And the newest meters, John, they actually will tell you, they'll wait and watch for stabilization of all the points and give you a green light to say, okay, now would be a reasonable time to take your sample. So it kind of shows in their world that they see the same thing, and we just need to take it by a case-by-case basis, right?
Yeah, so there's a few other things you wanted to say about lighting. One was fixture versus switch.
Yeah. There's been a discussion back in the day when we talk about the olden times, John, what we did. There was a perception that if you went to the meeting room that I'm in now let's say it has 9 fixtures on one circuit. The easiest way was to go to the light switch. And especially if it was a duplex and you had 2 circuits of 9. But the thought process was that if you take a measurement at the switch and it's of 9 fixtures, then you have taken 9 samples for your statistical sampling. Well, that was the old way of thinking, and you realize that there could be some highs and lows within those 9 that you're just going to average out. So different thinking, right? Now it's that we have to take more samples. And I used to be a little adverse to getting on a ladder to get up to measure an individual fixture. Obviously, the ladder's heavy, moving around, slows your time down, adds cost. But I have found that now with some of the LED panels that we're putting in, accessibility, climbing up above the ladder to easily get in, connect my equipment and measure, it can actually be quicker than taking apart light switches. But it does speak to when we put together our sampling plans for our projects, thinking through how are you going to go about that. As you mentioned, compared to India, throwing safety out the window, we can't keep up with that. But time is money. So again, for the audience, these are things you want to think through when you're developing your plan for M&D. Was that the point that you were asking about, John?
Yeah, so you're right, because there's I don't think that maybe I'm wrong, but I don't think that the protocols say, when it says, they might say take 11 measurements. And you might say, well, there's one fixture with 11, or no, I'm sorry, one circuit with 11 fixtures. I'll just measure that. That'll give me an average, and yeah. But that doesn't work with the whole sampling thing where you're supposed to find the variation and all of that.
Yeah.
So, I mean, because that's the whole point of the sample size or sampling thing is, how much does it vary from that, whatever the average is. Yeah.
I think that's a great segue, because that's something else that had improved. Like I said, back in the day, we would write these projects and we'd say we'll take some samples, right? We weren't very specific. And to your point, IPMVP doesn't designate specifically. It does say that you should take statistically significant samples, and we had to interpret this for ourselves as to how we're going to do it.
Right. Right.
And to your point, if you got 1,000 fixtures and you throw it into the statistics, it comes back and says you need 11, right? Well,
Right.
11 samples, assuming that the coefficient of variation is reasonable, rather tight band, then you're good.
Right.
Well, this adds a complexity to it. So if I go out in the field and I'm taking these data and all I have to do is take 11 and I'm done, you wait till you get back to the office and you look at it, now you've got a problem. So we're trying to move towards where we have the analytics in the field that says I took 11 samples, but now I'm checking the coefficient of variation. And because it was a little wider band, I need to take 12, 13 and keep going until I satisfy that, right?
That's right. That's right.
And now you think about it, when I talk about the model moving from our internal personnel to subcontractors, we've got to have that plan together. I always get a kick out of it, because if we give them the sampling plan, we'll say we need X amount of these and X amount of those, and they'll say, okay, just tell me where to go. And this is part of that real world we talked about, where I can't tell you. When you get on the job site, I have no idea whether that the room's going to be in use or full of storage. And
Right.
I can't have you freeze because you get on the phone to call me and say, you got to give me another one to go look at. So it really speaks to, when you're putting this plan together, I want everybody thinking, oh yeah, I got to think this through. You might not be able to avoid it all, but the idea of coming back and looking at your measurements and realizing I got to get on the phone and get people back in cars and go back out there to add costs, not a good plan, right?
That's right. Is there anything else about lighting that you want to throw in?
I think it's kind of a segue, because it takes us into metering, which is something I wanted to talk about.
But stop. I got a question or two on lighting before we get there.
All right.
Okay, so let's do. Here's a question from one person. He says, "What do you say to an ESCO who says we've done many of these types of buildings, so the fixture wattage is going to be this?"
Yeah. So this kind of ties back to our cut sheets, right? We know what it's going to be because it says that. So let's talk about that client's electrical infrastructure. If you're talking about 110 volts versus 120, we know the span of a normal circuit can be everything from typically 108, 109 up to like 124. Well, if you know your equation for wattage, that voltage varying is going to affect the wattage output, right? So the idea that you know is in a vacuum. It's not until you install it into their electrical infrastructure. And that ties back to our sampling plan. One of the things we ran into is, from an efficiency standpoint, if my client has 5 buildings, right? And I'm looking for the quickest way to get my measurements and get out of there, right? I could go to one building, but because statistically speaking for the entire portfolio, the other buildings may have variations in their transformers and their adjustments for their voltage that are going to affect it. Right. So we try to spread, still cost effectively, go to at least a couple buildings to get a better sampling. So my answer to that again is, it's in a vacuum, man. You've got to get out there and measure it.
Okay, so that's interesting. So, I think you answered this question, but I'm just going to have you say it more explicitly. So you have 5 buildings. The sampling methodology and all of that, you can read about it. It's in the different guides and all, but you have 5 buildings. Let's say you have the same types of fixtures in the 5 buildings. Rather than looking at them as 5 different populations, you'll combine them all into one population, just sample from some of the buildings, correct? You won't say, look, I need to get 11 measurements of 2 amp 4 foot fluorescence at all 5 buildings. I need 11 measurements at 5 buildings. You're not going to do that. You're just going to do 11 measurements, and it's going to spread out over the 5, correct?
Right. In my sampling plan, if I'm designating it for someone internal or for the contractor, I might not look to break it down to every piece. I mean, look at some of our customers are state representatives that have buildings that are all 4 hours away from each other. I can't practically get to every one of them.
Right.
But I will
That's right.
avoid the risk of doing, if all of the samples are capable of getting at one building, I won't do that. We'll look to spread them around to have a better sample. Something
Okay,
we didn't
let's move
mention
on.
that was the power factor, right? It ties in with the voltage, the power factor of not just the components, but some of the electrical equipment in the buildings can affect it, right? So just another example.
Okay. So you wanted to talk about metering next.
Yeah. So with lighting, that was the segue, was when we started this business, the amperage associated to the light fixtures that we were measuring was much higher. And for years now, as LED started, the amperages of this equipment started coming down and down. And this ties into, we talked about which meters we select, what calibration. Well, the current transmitters, I brought this one for a little show and tell. This is a 1200 amp current transmitter that might be connected to your typical power meter that you order. It might be capable of picking up the amperage of a light fixture that has a higher total wattage. But now that the wattages keep coming down, the realization of that just won't work. So it got back to us specifying, do we have the right size equipment for the job, right? So getting to smaller and smaller current transmitters, this one opens up, and this one has a max capacity of 5 amps. And even that, in some cases, we've got, small LED bulbs that are under 1 amp. So the point being, metering, we have to identify the right meters with the right functionality that we should put in our bid specs to our contractors. We have to specify the right peripherals for the load to measure, right? This has been a big change, and we've done our own internal documentation to improve our processes. And then, like we talked about earlier, we can't just hold that secret. We have to tell that to the people that were expecting it. It's been a bit of a challenge because, if it's a lighting contractor, their business is replacing lights. The metering is them being a part of a guarantee or performance contract, right? But that means they have to go buy these meters. They have to have trained technicians. But a big push with the metering equipment. You mentioned that there aren't really protocols about this. If they say, oh, how often should you calibrate your meter? I haven't found anything in IPMVP or FEMP that gives that guidance. So we had to make our own decisions.
I'm sure I've read somewhere they need to be calibrated every year. I'm sure I've seen that. That's what we do in Texas.
It'd be great if they've added that. A few years ago when I looked at it, I had to go back and often what I think they said was according to manufacturer specifications, which is if you call the manufacturers, they'll give you it depends, right? How the bigger problem is some of these meters are, they're out in the field. They get bounced around in trucks. So there's a dependency there, but realistically, your meter after being calibrated, something could go wrong.
That's right. That's right.
And I do want to tie that back because it comes back to the sampling plan. When we go out there, we don't want the measurements to happen in a vacuum. Like if I don't tell you that fixture we talked about, 57 watts, when you go to measure it, if you get a number on your meter, how do you know if this is in alignment or not? That data needs to be in the field. And if that data comes in alignment, then you have some high confidence we're in the right ballpark. If it doesn't, you may need to stop and question, is something wrong? Is my meter set up correctly, right? So yeah, it's a big podium for me is about the meters and the accuracy these days.
This is just a shout out to Mark. Mark, you commented a little bit. Can you tell us if there are any of the guidelines or standards that say anything about calibration? Mark will let us know in a minute, and we'll interrupt. Right. I got a question here, and that is, how often do you need to remeasure lights during the guarantee period, performance period?
Good question. I'm going to tie this back to when I talk about the M&V plan for us, what we put together. I talked about having a better plan of specifying what you're going to do and accountability with your customer or transparency. So oftentimes we have clients who initially may want the most robust M&V, right? and then they see what it costs or what it'll take. Lighting is one of those places where we do get comfortable, especially with LED, relatively stable. We see, lamp life lasting so long. The idea of not doing M&B or not redoing it every year, I've seen that we got comfortable with it. To me, I think there is a stability in it, but I wouldn't mind seeing, if it's not an annual, maybe every couple years. One of the things that I see that fades the performance of the lighting as intended isn't that the fixtures fade that much. It's that the maintenance staff, did they keep up? Did they put back the same wattage equipment, right?
Right. They put the old lamps back in because they're reusing their fluorescents that are still in the closets, and they might as well use them up and throw them away.
So it might not be necessarily a robust going out and remeasuring, but having something on, let's say if we have site visits with a client, to go back and ask them, what are you buying? What problems are you having? What are you seeing? So everything is cost driven, right? The cost to benefit. If we put together an expensive plan to go back, check lighting, and every year it comes back spot on, maybe that's not the best choice. But there should still be spot checks depending upon the project periodically to check on. I think that's
okay. So what you said is there should be, but in my experience, and look, I haven't worked for an ESCO in a long time, but I've worked with ESCO. It's not done, and I'm not saying it's bad that it's not done. I don't really personally don't think it needs to be done, but I could be totally wrong here. But generally, the measurement's just done once, and that's post retrofit. We've measured the fixtures before and after, and we'll just assume the savings is going to be the same every year thereafter. I mean, that's pretty much what you've seen also, correct, Robert?
It is, and I think there's a balance too. Listen, we have clients where we'll develop a project that could be projected out for 10 or 15 years. We get 3 or 4 years in, and we see a good, stable performance. Now you start to question, well, how long do I have to watch the pot, right? So I think there's a reasonability to it, right? Whether we apply it to each one. Now, having said that, I also know that when we have clients who maybe we discontinue, we agree that it's been achieved and we cancel the guarantee, that if you're not doing some sort of spot check, guess what happens, right? Overrides, schedule changes. They purchase the latest, the cheapest bulbs that Grainger has available, right? Instead of putting back what was designed for the project. So I don't know that there's a one size fits all, John, but I think that's where the cost to benefit of how ongoing M&B is where the balance is, right?
Okay. Back to metering, you already mentioned was you want the right size meters for the loads that you're measuring. Is there anything else on metering that you want to throw in there?
I can get into the weeds with it. There was the story of I think you got a kick out of it when the 3-phase metering I was doing, and surprise, surprise, I had one of the phase wires come disconnected. I had a 3-phase metering opportunity on an air handler motor, and while doing the measurement, live measurement, had my arc flash gear on, you're in an electrical cabinet with some heavier gauge wire that hasn't been moved. It doesn't like to move. And now you have to get in there and install your current transmitters. And even doing everything carefully, while I was installing one of the 3 current transmitters, the wire came loose from the lug. It actually popped free. Now, the motor is still trying to operate on 2 phases. I essentially have a live wire in my hand that I don't want to short out to the cabinet in arc flash. Thankfully, I had my associate there for, gathering data, and was able to ask them to go turn off the disconnect. They were able to turn off the disconnect. We were able to get the lug remounted. So kind of a near miss experience, things that sometimes you just can't account for. But I'm sharing this story because this is the real world of what it takes to get out there and get these measurements. Some of this equipment is 50 years old. The due difference was, admittingly, some of my safety practices. Now I will utilize a thermographic camera to use to get an image of the electrical wiring to verify that there isn't a loose lug. We might be able to identify a hot spot where there's a bad connection, and perhaps avoid that as a location for measurement. But it's another real world story of equipment. I'll tie on to another one because of a metering piece. But when we go out to do this metering, our projects have a timeline. a flow. And you mentioned this before about taking combustion measurements in the summer, right? When you're planning your projects, we tend to build it in a vacuum, right? We look at our clients' buildings, we identify their baselines, and we propose these ECMs and even the methodologies of how we're going to do it. But what is the timing, right? When are we going to get these measurements? If it's a boiler that's in the summer, that's going to be a tough one to capture, right? If it's a chiller in the winter. So planning the logistics of it is one big part. Then you have to think about if it's in operation, if it's an industrial application, you can't just go in there and start cycling. So if you have a variable load, right? I could be capable of doing it, but I'm not responsible for doing it. And I don't know what ramifications if I start speeding up a pump or slowing it down. So the logistical coordination with your client and the right personnel to make these changes so that I can get my meter installed and capture this. Nothing's worse than when you think you're ready to go out there and do it. You've got the people, you've got the laborers there, and you can't do it. So that was a big one for me, I think, is conveying for these projects. We got to think about that in advance, right?
So here's a question. So I'm sure you've measured or monitored a lot of chiller plants. Is that correct?
Mm-hmm. Yeah. Yeah, a lot of, I typically I won't go to India. I'll do up to 480 volt, John, and then I call, then we're calling the electrician.
No, then you call an electrician, absolutely. No, I've done these, I did a chiller plant once and I was scared. I was really scared and I didn't know what I was doing. I didn't have gloves. I didn't know any of this safety crap. I just took my ring off and no idea what the voltage was, but I know there was some pretty huge copper plates there I was measuring, and it was a live load. And I mean, I guess most of us survive, but it only takes one person to die or to get really injured, and then you realize, I guess safety is really important. And so it's silly to be flippant about it. It's like, yeah, you survived, but if one doesn't, then that's a different story.
So, I guess for the audience, yeah, you want to have confidence in who it is, and even down to someone who does it. I don't like to not do measurements for a long period of time. It's not something that you want to pick up every once in a while. You have to stay in that mental state because I have my own safety protocols, and I'd like to think that they're above anybody else's. If I open a panel and I really need to get this measurement, and I open the panel and I don't like it, I don't get a good feeling about it, I walk away. It's just that's not worth it. So yeah, you've got to have a good sense about it. You made me think of something that I wanted to share with the group that some people know it, but not everybody. When it comes to a VFD, variable frequency drive, the nuances of, and I'm not going to begin to attempt to educate on how a VFD works, but it does some things that converts from AC to DC and back again in order to vary that frequency and speed up or slow down a pump or a motor, right? And one of the experiences I had, I was installing, it was a power meter, and it was not a temporary meter, it was permanent installation. And when I connected it, I connected the current transmitters downstream of the variable frequency drive. And initially, I wasn't getting any readings, and then it popped a fuse. There's one of three. So I went and I found another fuse and I put it back in, and this time it didn't pop the fuse. I'd say I blew a smoke seal, right? The electronics of this power meter actually smoked. And what I learned that day was that what a VFD does to the signal does not play well with current transmitters. Not only will you not get a good reading, but some of them can't handle it. And I've seen on job sites, we had a project where the design was to use the client's current sensors that were mounted to their building automation system.
Right.
And these ones didn't smoke, but the data was not good. And what we found was somebody mounted them downstream of the VFD. So I thought I'd share that. It's not a common knowledge, but if you can still measure that equipment, if it's isolated, you just go upstream to a disconnect or to the motor control center. Again, this kind of ties into, we get a little complacent when we're designing these projects to say, yeah, sure, we'll just send somebody out to get some measurement. So my hope is that the takeaway is not to scare, but to say, you got to think this stuff through in order to have good quality measurements, successful.
Okay, so let's talk about, let's say you're going to do a chiller plant and you have variable flow. So you have you're going to measure GPM, chill water supply, return temperature, chiller kilowatts. I think
Yeah.
that's, and you're going to put data loggers out, or not data loggers, but you're going to log the data. So you have your own measuring stuff. It's not necessarily going to be from the BAS.
Okay.
Um, you need to measure it, let's just say, for a year, all the time. What we used to do was we would set the equipment out and we'd come back in like a month or a couple of weeks to see, is it still working? Because often it did, they just kind of stopped working for some reason,
Yeah.
or maybe. Can you explain how you handle that, the whole idea of, are these sensors continuing to work or not?
Yeah, so that's the beauty of having done this for a long time. You learn from your mistakes, right? So what you just said was kind of interesting. The data loggers, we use a lot of Hobo. No, nothing shout out for them, but just the idea that you can launch these loggers, right? You go out in the field and they're as easy as pushing a button. And on a motor logger, you set it on the edge of the motor, and the way it functions is it senses the magnetic field. There's a little read switch in there. Well, you push the button and you walk away and you're like, okay, is it working? Is it capturing when the motor's on and off? So I think
That's right.
yeah, you hit a good point to say, don't just do that, because you come back a month later and the project timeline is moving ahead and you need this data and you find out it never turned on.
Right.
So I think that's great. I think that what you just said, it ties in again with thinking ahead. I'm going to go to the other extreme, which is hindsight 2020. When you're writing your agreement or your plan, assuming everything goes perfectly, you're fine. Well, we learned that it doesn't. So starting with, when you write your obligation to your client, what I'm going to do, how I'm going to collect this data, right? It's not crazy to say, I'm going to put a blurb in there that says what we might need to do if or then, right? If we lose data, we may have to identify an alternate solution, right? And this is where you get into the experience and reasonability, is to say, well, how are we going to solve that? You're talking about a data gap, right, John? So what are some reasonable methodologies? You could say, well, we took the data from the previous day where it was at similar load or it was a similar temperature. And as long as you apply a reasonable methodology, that's step one. Perhaps step one is contractual, right? What did we say we're going to do? But then the alternate is to say, give a reasonable solution that is defendable. And the final piece is to be transparent. This stuff happens all the time, and we don't have language in the contract, and somebody has to sit down and come to an agreement as the best way to do this. We're smart people. We know how to figure this stuff out, but just being transparent and providing that, without giving you a specific example, that's what I do.
I totally agree. It's super important, at least in the M&V report, to say, look, we measured everything. We thought it was all going to work, but we lost 3 months of data. These things went down. So what we decided to do was, and explain what you did, why and if it's reasonable, and it probably is, it'll be just fine. And that happens. I guess another way around it, I mean, this is maybe where the old school people are thinking too old school, and that is the new data loggers, they can attach, what's the word, you can see the data online, and so you can see right away whether they're working, and you can also check in a month later or every month and make sure everything's still working, and then you don't have to keep coming back there. That's another thing that actually,
the technology might make it easier, but the principles still apply. You should still check.
absolutely.
You made me think of something with the chill water. If you're measuring for BTU, you've got 2 temperature sensors and a flow, right? We had a project where when you shut off the chiller, it's easy to think, okay, well, the water stopped moving, but it didn't. Number one, there was some inertia. Number two, as the heat is absorbed, the water is changing temperature. It actually creates its own flow in some cases. So you might have a BTU meter that is picking up a slight delta T and a minimal flow, but that's actually adding to your total. So now you get back to where you're going to have to look at your data and scrub it and maybe say anything below this I know is unreasonable. It's not when the chiller is operating, so don't use that, don't include that in your total, right?
That was going to be my next question, is how do you deal with that? Do you have certain rules? I mean, you can't just say, look, the chiller just turned on, we'll get rid of the first hour's data. I mean, that's pretty hard to do.
Well,
How do you do that?
I think it kind of ties when we think about utility metering, right? If we look at a utility meter, we think of a blended average. If the customer doesn't have much consumption and they have a $50, $80 meter charge, then it's going to exacerbate the rate. But if your chiller is operating all summer and there's this 4-minute window where it does some erratic things, but it really is a gauge, right, as to whether it's going to have an overall impact. And then in those examples where you think it does, then you could set a status to say no, track when the on-off status is and delete that time period. Again, somebody saying, well, you're going to delete data, that could be modifying it. If you understand those ramifications, right? And actually, we want to talk about that. The lighting samples. If you get a bad sample, statistically speaking, you're supposed to keep it, right? Well, that's unless you have a known quantity that it is truly an error. And this is my opinion, but if you have that, you can record it and then you can denote what the anomaly was and why that wouldn't be included, right? Because the outcome of using it may be worse, right? So you can't do it inexplicably. I don't like that measurement and it doesn't reflect the way I want it. No, but if you have such as the chiller, the operating, the instability initially, and you remove that data, be transparent, let it know, and you can get better data.
That's good. I'm glad that you brought that back up. I mean, we've totally missed that. Okay, so one way we do M&B is for air handlers, we will look at we'll look at the supply air temperature, mixed air temperature, return air temperature, outside air temperature, and maybe the flow rate. I mean, often not the flow rate, but maybe the flow rate. And so then you can figure out the outside air percentage from the 3 temperatures, the outside air, mixed air, and return air. And sometimes you end up with stuff that doesn't make any sense. You get negative outside air or 100% outside air. How do you deal with that?
It really falls in the same category. If you have those concerns, putting in a alternate resolution, right? If you fear you're going to come across that, but look at it. If you're looking at, it's unlikely that there's only one air handler. If you had a bad outdoor air temperature sensor, it could be global, but you might have other data that's representative that you could use that would fix your calculation. In some cases, if it's bad and you don't have an alternate, you might have to propose another solution. I would love to tell you that I have a end-all catch for these things. But I think what we talked about previously was providing good engineering practices, assumptions that was used, and not only being transparent, but provide it as an opportunity. Tell the client, here's what we have, here's what we're proposing. Or if you have an alternate that you would prefer, we'll hear you out. But this is where the art of what we do comes into play, right? And then if you get to be an old timer like me, we share these stories so that somebody coming down the road behind me can plan ahead, right? Maybe it is to question the data or the points. If we're going to use an existing BAS system or data that was old, we might plan ahead and use our own alternative. These data loggers now, I can mount a device that measures all 3 of those in duplicate so that I have that precaution, right? It's not that hard.
So what about a chill water plant, and your BAS is monitoring the supply, chill water supply and return temperature and maybe the flow rate too. But you're also, I don't know why, but you're also data logging it and your numbers are totally different. What do you do then?
You could do a comparison. You bring in a third component to go test. So say after the data you've collected and you're questioning which one is correct, go back if you have access to go do a third temperature to say, it's like getting bids on contractors, which one's more reasonable. Go back and validate which you believe is the better data. It really depends on, you made me think about this, and I apologize. Does that answer your question, John?
Yeah, yes, it does.
Yeah. Metering. I wanted to circle back to this because you've heard me mention that there's cases where we'll use the client's equipment meter, BAS, or whether we're using a utility grade meter. Maybe it's an aftermarket. One of the things that I think it's important that we think through is, again, in a vacuum, you go, this is great. We don't have to buy and install a meter. They've got a meter. Okay. What happens if the meter that's being used for your purposes of M&B goes bad? What happens if it needs calibration? So the question is, who owns it, right? Now, if the client owns it and we need the information, it may not be in their greatest interest to get off their butt and go fix it. All of a sudden, it's our problem, even though it's not our responsibility, right?
Right.
You have to think about those dependencies going into the project. And these days, with the cost of metering and becoming more achievable, I'm a big fan of putting it in. And you may get some redundancies that ties in with what you said. I'd rather have choices and options than nothing, right? But I do get frustrated if we're dependent on somebody else's meter. And even look at option C, we're dependent on a utility grade meter. And you know, as stable as they are, they don't always stay that way. So planning ahead.
Yeah, there's a lot of problems with that. We have 5 minutes left. What can you think of that you wanted to say and we haven't gotten around to?
Well, I think, you know, the message I'm hoping to convey is I can't give all the answers, right? Understanding the challenges of these field measurements. From the start of whatever your project is, take these things into consideration, attempt to plan for them. You might not save it all, but the outcome is going to be better, right? I think the accuracy component of what I talked about with measurement, it needs to be considered. And depending upon who you are in the project's life cycle, you might have to educate yourself, right? Or lean on those who can and bring those people in, again, for a higher quality product on the output. I guess that's my hope of the takeaway, is that if you're thinking about the stories that we've shared and your role in the projects, how you can help impact that, is to ask questions. Think about these stories and what you could do to modify your plan for a better outcome, right? Yeah, I think that's my key takeaway.
Last word from Robert. Do you have anything?
I just wanted to say thanks, John. I don't know of another forum that what you put together. I mean, I've known you for years in the option C or metrics world, and I think it's great that you're putting these calls together. You know, it's one thing we get to these exhibitions, AEs and whatnot, but that's a bigger investment. And I think it's great. You're pushing Clippinger, I know you've had on, and I appreciate the opportunity, man.
Well, thank you. Thanks a lot, Robert. That was really good. Thanks everyone for coming. We'll see you next month.
Thank you.